So 19 and 20, super friendly. This is part 2 for section 1.8. To make a decimal into a percent, I move the decimal 2 places. To make a percent into a decimal, I move the decimal 2 places. Here, to make a decimal, a percent, or into a percent, I move the decimal 2 to the right. Just like, it's exactly the reverse. When I made a percent into a decimal, I move the decimal 2 to the left. When I make a decimal into a percent, I move the decimal 2 to the right, and then I add a percent sign. So in problem 20, 4.02225, I'm going to take the decimal, move it over 2 so it's between the 2's, and I'm going to add a percent sign. Most of the problems that I've done so far, I've done them just the way that they're normally taught. This next problem, making a fraction into a decimal, there's multiple ways to teach that, and I usually teach it by long division because that's how I was taught. If you're working ahead, which I encourage, and you did this and you get a right answer, you don't have to follow my lead. But if I was making a fraction into a decimal, I'm going to do a long division, put the denominator outside the division bar, the numerator under the division bar, and because it's going to need a decimal, I'm going to insert that decimal after the 2, and I need to start adding zeros because 5 doesn't go into 2, so I'm going to add a 0, and I'll say how many times does 5 go into 20? Well, it goes in 4 times because 4 times 5 is 20. And now, once I get a number on top of the division bar, I multiply, I go 4 times 5 is 20. And I made these really nice one-step problems. Again, I lean towards using my calculator for decimals. I'm just more comfortable on my calculator, and we don't do a lot of decimals. So that's actually my answer, because I've got no remainder. And instead of writing a decimal first followed by the 0.4, in my answer, I'm going to precede the 4 with a 0. For making fractions into percents, it's just 2 steps. First, make the fraction a decimal by, for me, long division. I don't know that I could go directly from making a fraction into a percent. And I'm very consistent. I always make my decimals by doing long division. So I'm going to put the denominator 12 outside the division bar, the numerator 9 under the division bar. I'm going to put a decimal after the 9 and start adding zeros. First, I ask myself, how many times does 12 go into 90? I do 90 divided by 12, hit my SD button. The number to the left of the decimal is what goes on top of the division bar after the decimal, that's a 7. And now I'm going to go 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. I'm going to borrow 1 from the 9 and make it an 8, make the 0 a 10, do 10 minus 4 is 6, the 8's will cancel. Since I haven't got to a termination, I'm going to add a 0, bring it down, and I ask myself, how many times does 12 go into 60? If I don't know that, I just do 60 divided by 12. 60 divided by 12 is 5. That's what I'm going to put on top of my division bar. And now I'm going to go 5 times 12, and 5 times 12 is 60. I'm going to subtract and get a remainder of 0. So the first thing I've done is I figured out that the fraction 9/12 is equal to 0.75, which I'd write as 0.75. That's not done because I'm asked to make a percent. Super easy. How do I make a decimal percent? Just move the decimal 2 to the right. So I'm going to take the decimal that's provided and move it 2 to the right and add a percent sign. So for 24, my answer is going to be 75%. All right, so now a jumbled problem. Problems 25 and 26 have tables that they want me to fill in, and most of the skills that we been taught we need in these. So I'm going to work with 26. I'm going to take 3/4 as a fraction, write it as a decimal, and write it as a percent. So first, in 26, I'm going to change the fraction 3/4 to a decimal. And pretty easy to do that. To make fractions in the decimal, I do long division. The long division I'll do is I'll divide 4 into 3, bring a decimal, add a 0, bring that decimal up. Then I ask myself, 4 goes into 30 how many times? That's small enough I can do it without a calculator. I'm going to put a 7 up top. 7 times 4 is 28. I'm going to subtract. I'm going to borrow 1 from the 3 and make it a 2. I'm going to change the 0 to a 10. I'll do 10 minus 8 is 2. I have a remainder, so I'm going to add a 0, bring it down. Then I say, how many times does 4 go into 20? It goes in 5 times. Then 5 times 4 is 20. Subtract it, I get a remainder of 0. That's the decimal version. So the decimal version of 3/4 is 0.75. I'm going to fill in a 0 behind it just to make it look better. That's that's the hard part. Now, I'm going to change 0.75 to a percent. And this is a skill that we've just done. To change a decimal to a percent, you just drag the decimal 2 to the right. I would get 0.75%. That 0 preceding the 7 has no significance, so I'm not going to write it. Done with the first line. Your first line you probably can do in your head. I tried to make the numbers tolerable. Now I'm going to work on this 0.28 and first make it into a fraction, which is harder, then make it into a percent, which is easier. So now I want to change 0.28 to a fraction to fill in that middle row of my table. Easy enough to do. I'm going to write the 0.28 so it's not a fraction, just write a 28 in the numerator of a fraction. In the denominator, I'll put a power of 10. In this case, it's going to be 1 followed by 2 zeros because there were 2 numbers behind the decimal. And now I'll reduce. The factors of 28 are 1 and 28. They're 2 and 14. They're 4 and 7. The factors of 100 that I'm going to need is 4 and 25. I'm going to simplify like I did at the beginning of simplifying. I'm going to write 28 as 7 times 4. I'm going to write 100 as 25 times 4. And reduce, I get 7 over 25. For the fraction version of 0.28. The next step, I don't need any side work. To change that decimal into a percent, I just move the decimal 2 to the right. So to fill in the rest of that middle row, I'm just going to move the decimal 2 to the right and add a percent sign. Bottom row, first I need to change the percent to a decimal. To change a percent to a decimal, you just take the decimal and you drag it 2 to the left. So I'm going to have a decimal, and after the decimal, I'm going to have a 60. And preceding the decimal, I should have a 0. It probably would look better if I didn't have that extra 0. So I would say that answer is okay, but it would be better if I wrote 0.6. It'll be better for the next step because it's going to make it a lot easier to make the fraction. So almost done. I just have this, and what I need to do now to fill at the very bottom of this table is I need to change that 0.6 or 0.60 to a fraction. And anytime I'm given a decimal, I'm asked to create a fraction, I write the decimal without the decimal, and in the denominator, it's going to be a 1 followed by as many numbers where after the decimal. Here, there are only one number after the decimal, so it's going to be 6 over 10. I'm just going to divide by 2, divide by 2. And this is going to be 3 over 5. If I put anything on the test from this chapter, this feels really nice and test-worthy. It has all the skills, changing between fraction, decimals, and percents. Numbers aren't ridiculous. This is important. We might see it again a little bit in this class. The rest of the section has to do with categorizing numbers. Boy, I remember this when I was a student, and I struggled a little bit, so I tried to type something up. So for our class right now, we're going to classify numbers as 5 large categories: counting numbers, whole numbers, integers, rational numbers, and irrational numbers. So there's 5 different categories of numbers that we're going to concern ourselves with. And there's overlap. I was trying to figure out how to explain this well, and I don't know how this is going to fit. But if you ask me where I lived, I can say I live in Phoenix, Arizona. I could say I live in Phoenix, or I could say I live in Arizona, or I could say I live in the United States, or I could say I live in North America, or I could say I live in the Northern Hemisphere. These are all correct about where I live. They're just broader and broader. And that's kind of what this is. The lists here get broader and broader for the most part. So numbers can be classified based on their characteristics. The first kind of number I mentioned is counting numbers. In counting numbers, in Math 142, if you take it, they call them natural numbers. And they're used to count physical objects, like I have 1 calculator, I have 2 pens. So numbers 1, 2, 3, 4, 5, doesn't count 0, doesn't count negative numbers. The counting numbers are just exactly, they're easiest to identify. Any number starting on 1, counting up by 1 are counting numbers. So counting numbers start with 1, increment by 1. And I don't know the big deal why we call whole numbers, make a whole category of numbers by just adding 0 to counting numbers, but whole numbers are counting numbers plus 0. So the number 4, it's a counting number because it's in my list of counting numbers. It's also a whole number because it's in my list of whole numbers. So counting numbers start at 1, go up forever. Whole numbers start at 0 and go up forever. Integers are counting numbers and their opposites and 0. So all the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, are integers. The opposite of every counting number, -1, -2, -3, -4, -5, are also integers and 0. Basically, positive and negative numbers along with zeros that don't have decimals are integers. So integers are negatives. They include 0. And they go on forever. These dots in my list mean I just got tired of writing, but there's a lot more integers. There's many more. There's infinitely many counting numbers. There's infinitely many whole numbers. But I'm just recognizing the pattern. So counting numbers start at 1, get increment by 1. Whole numbers start at 0, increment by 1. Integers, maybe I can say start by 0, increment 1 to the right, increment 1 to the left. Those are the freebies. Those are numbers that I'm real comfortable with. The next category is rational and irrational numbers. They're maybe not as easy to explain. And rational numbers, technically, they can be written as a fraction. So technically, when I see rational numbers, I think fraction, which means like 7 is considered a rational number because I can write it as a fraction. It turns out that any number that has a decimal that repeats, there's a way to make any repeating decimal into a fraction. So really, rational numbers are either written as fractions, they're an integer that I can write over 1, or if they're written as a decimal, any decimal that repeats, there's an algebraic algorithm or strategy to change repeating decimals into fractions. So rational numbers are fractions, integers, and repeating decimals. Irrational numbers is any number that's not rational. So in the world of numbers that we're being exposed to right now, numbers are either rational or irrational. There's no middle ground. In irrationals, if to look at them, they have a decimal that doesn't repeat. They have a pi in them, or maybe like 5 pi or 7 pi. We haven't talked about e yet. E is an irrational number. I don't show it in the homework. Or it's a square root that's not a perfect square root. Like if I did square root of 5 on my calculator and SD'd it, it's not a perfect square root. It has a decimal pattern that would go on forever. This is just as many digits as my calculator knows how to give me. If I had a more expensive calculator, I'd probably get another 6 digits. So irrational numbers are decimals that don't repeat, that go on forever. And without the ... a terminating decimal is actually a rational number. Should have said that up here. A rational number is also a terminating decimal. So irrational, a non-terminating, non-repeating decimal, something with a pi, or a square root of a number that's not a perfect square. And then all the numbers on this sheet are considered real numbers. I don't know how well that does here, but here's a picture. So all the numbers that we have are real numbers. So in the world of real numbers, the biggest categories are rational and irrational. To be irrational, you have a non-repeating, there's no pattern, and non-terminating, it doesn't end, decimal. So something like 4.132976 ... indicating there's no pattern, that's an irrational number. It has a pi or some form of pi, like 3 pi, or it's a square root of a not very nice number like the square root of 2. The square root of 2 on my calculator leaves it as a square root of 2 to give the decimal. I hit the SD, and it just gives me a jillion decimals. That's a repeating decimal because it's non-repeating, there's no pattern, it's an irrational number. For a rational number, it's either going to be written as a fraction, could be written as an integer. Any integer could be made as a fraction if I just throw it over 1. It could have a terminating decimal, or it could have a repeating decimal. These are the hard ones to pick out. The other categories I think are obvious. So a fraction like 2 over 3, an integer like 9, a terminating decimal like 14.216, or a repeating decimal like 3.45 repeating. All of those will be rational. So now we're going to go through and look at some problems and just figure out which of the numbers fit the categories. So we'll do all these together, so we'll even nail these for homework. So immediately 27 says, which of the numbers are counting numbers? Well, counting numbers start at 1 and they go on forever. Well, pi isn't a counting, 7 is a counting number. In my list of counting numbers, if I made it go further, 7 would be there. Pi, I think this calculator has a pi button somewhere. It's down here, yeah. So shift pi. Pi is not a number without a decimal, so that's no good. Fractions don't count as counting numbers, so that's not a counting number. Square root of 16, well, that's actually just equal to 4. That is a counting number because it's equal to 4. Square root of 7, it's a decimal. It's not a counting number. Counting numbers can't have decimals. They have to be positive. Negative 12 isn't a counting number because it's negative. 5 1/3 is not a counting number because it's a fraction. 0.23 not a counting number because it's a decimal. 6.251 not a counting number because it's a decimal. Counting numbers don't have 0. 14 is a counting number. Negative 5/4 is a fraction. It's not a counting number. So if I went to answer problem 27, which are counting numbers, the number 7 is a counting number. Square root of 16, which equals 4, is a counting number, and 14. I'll go through my list and try to do the same for problem 28. Maybe pause the video and give it a try. So for 28, anything with a pi is not a counting number, any fraction's not a counting number, any decimal's not a counting number. Counting numbers don't count negatives, counting numbers don't count zeros, counting numbers don't count decimals. Counting numbers do count nice square roots, and I think the square root of 4 is a nice square root. The square root of 4 is just 2. So square root of 4 is considered a counting number. But the square root of 10, when I hit equals and it gives me the square root back, it means it has an ugly decimal. I hit the SD on my button calculator to get the decimal. Square root of 10 has a decimal. No good. So the only number in my list that fits the category of 1, 2, 3, 4, ... is the square root of 4. Next, we're going to be looking at integers. Integers, are counting numbers and their opposites along with 0. Just as long as I don't have a decimal, I'm okay. If I have a decimal or a fraction that doesn't reduce to an integer, it's not good. So in 29, 7 is definitely an integer, it's not a decimal. Pi has that ugly decimal, it's no good. 5/3, it doesn't reduce to an integer, it's no good. The square root of 16 is equal to 4. 4 is not a decimal, that's good. The square root of 7 is an ugly decimal, that makes it not an integer. Negative 12 is not a decimal, negatives are okay for integers. 5 1/3 is a fraction, it's no good. 0.23 is a decimal, no good. 6.251, a decimal, no good. 0, okay in the world of integers. 14, okay in the world of integers. As long as it's not a decimal, I'm good. Or a fraction that reduces to a decimal. And negative 5/4, that reduces to negative 1.25. So the numbers 7, square root of 16, negative 12, 0, and 14, I would call those integers. In my list of number to figure out the integers, pi's aren't integers, fractions that don't reduce to integers aren't integers, decimals aren't. Negative 24 doesn't have a decimal, that's an integer. 0, that's an integer. Decimal, not an integer. The square root of 4 is 2, so that's good. And the square root of 10 is like 3.16. It has a decimal that goes on forever. That's not good. So in my world, the integers for problem 30 are negative 24, 0, and the square root of 4. Rational numbers. To be a rational number, did I save that sheet? To be a rational number, either a fraction, an integer, a decimal that terminates, or a decimal that repeats. Basically, if it's not one of these three things, a pi, a non-repeating, non-terminating decimal, or a square root that's not perfect, then it's going to be rational. So as I go through this, I ask myself, is it an integer? So I'm looking for integers for rational, fractions, terminating decimal, don't have a dot 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 after it, or a repeating decimal. Any of those are considered rational. First one, 7, that's an integer. Pi's are always irrational. 5/3 is a fraction, that counts as rational. Square root of 16 is 4, that counts as rational. And the square root of 7 is 2.64575131. It has a decimal that goes on forever. It doesn't terminate and also doesn't repeat. That is not considered a rational number. Negative 12 is an integer, that's rational. 5 1/3 is a fraction, that's rational. 0.23 repeating is a repeating decimal, that's rational. 6.251 is a terminating decimal, that's rational. 0 is an integer, that's rational. 14 is an integer, that's rational. Negative 5/4 is a fraction, that's rational. So my answer to 31 is going to be 7, 5/3, the square root of 16, negative 12, 5 1/3, 0.23 repeating, 6.251 terminating, 0, 14, and negative 5/4. Most any number I can think of is going to be rational unless it's a square root of a non-perfect square, or if it has a pi, or a decimal that doesn't repeat or terminate. For my problem 32, I'm getting a little bit long here, which are rational. Pi's aren't rational, and square roots that aren't perfect square roots aren't rational. And everything else, this is a fraction, repeating decimal, integer, terminating decimal, and that's equal to 2. Everything other than the pi and the square root are going to be rational. So for my answer for 32, let me just box these and say that's my answer. Lastly, 33 and 34 want irrationals. Basically, to be irrational, it's going to be a square root of a non-perfect square. It's going to have some sort of pi in it, or it's going to have a decimal that goes on forever that doesn't repeat, and I didn't put any of those in there. So I look at problem 33, there's a pi, and this square root of 7, those fit non-perfect squares and pi's. Everything else is clearly not irrational, other than maybe that decimal that repeats. But to be irrational, your decimal can't repeat. So for problem 33, the irrational numbers are the square root of 7 and anything with a pi. Lastly, for my problem 34, the irrationals are anything with a pi, any square root that's not a perfect square, and then if there was a decimal, it would have to have a dot, dot, dot without a bar over it. And I don't see that. So for my 34, the irrationals are square root of 10 and 2 pi. It's a little bit longer than I wanted this to be, but let me stop it now. We just have one more section left in chapter 1.